Now we will continue with novel ingredients and technologies for food application. So, one of the most important ingredient itself is a protein. Yeah, protein directly as a food application or protein as an ingredient, protein as a food product. So, how do we extract protein? It's pretty much a straightforward process. Yeah, and the flow diagram what you see on your on my right side is whatever is the source of the protein, pre-treatment, grinding, milling or defatting, removing lipids, alkaline extraction, centrifugation, you get alkali extract. Here instead of centrifugation you can have a membrane to remove the alkali versus residue. Then use a conventional method of isoelectric separation or precipitation. You centrifuge it, again you can use a membrane here to get your protein pellet. This is pretty much standard process everywhere used for protein extraction, whether it is grain, oil seed cake, fish, what you have already done, or whelk or shells. Any of the biomass, this is pretty much the standard process. We have already discussed the concentration of alkali, ratio weight by volume, pH 8 to 12 or whatever depending upon the best solubility profile of a protein, targeted protein, time and temperature. So, how do we decide what is the best pH for protein extraction? One way of doing that experiment is, if suppose your target is fish protein from salmon or any source or from chickpea or any of the grain crop, buy that commercial protein and make different pH alkaline solution and to see where is the maximum solubility. Yeah? A, that will tell you what should be the pH. B option, what should be the ratio. Yeah? If suppose your ingredient contains 20% protein, that means in 100 grams you are using a biomass, that is 20%, and what is the solubility of that protein in alkaline solution. That is indirect way of measuring what should be the ratio. Yeah? Other one is from the literature. Yeah? But literature is better to confirm yourself. While doing so, you will come up with your better idea. To start something, to achieve something, start something. Yeah? Otherwise, you will be keep reading, keep doing it and keep making permutation and combination, and when you go and doing experiment, you will be starting at completely different pitch. Yeah? So, that is all to do with selection of conditions. Same thing applies for.
Sir, could you just elaborate thing on the ratio part?
Okay. Now, when it comes to ratio, I'll just go on. Okay. When it comes to ratio, yeah. Now, if suppose I will put it in this way, because I did discuss this before. If you want to dissolve 100 grams of sugar in water, yeah. So, how much of the ratio of the water you should take? Equal amount of water, double of it, 10 times or 50 times. More and more water you add, faster will be the solubilization. Yeah. So, that is one thing is solubility of that particular ingredient in that particular solvent. I will make it more complicated. If you have 10 grams approximately sugar in sand and your purpose is to remove that sugar from sand. Yeah? So, how much water you should use depends upon three factors. Number one is the solubility, A. B, how much water you take it out, how much ever water you are using it, you have to remove that much amount of water. So, there will be energy requirement. More and more ratio you put in, better will be the extractability, but you have to compromise between its removal efficacy. Once you take a solvent, then you have to remove the solvent. So, that means you are inputting more and more water. Three factors, remember, solubility and amount of energy it will require to add water and the cost of the solvent as well. So, those three things becomes an important part when we use the ratio. Yeah. So, it all depends upon what is the solubility of your targeted compound in that particular solvent. that is also the decision to see whether you can have a mixture of solvent to get better solubility. If you see in the case of bioactives, mainly water is used or 80% methanol is used, yeah, because methanol can bring in polar and non-polar phenolics as well, yeah. So, that is all depend upon your target compound, yeah. Did I answer your question? Yeah, sorry. So, that is one. Now, how we can use a new technology? Technology either in protein solubilization and separation by membrane filtration, agree over here. Protein solubilization, membrane, and then straight away spray drying without going for isoelectric precipitation. In case if you are using water for separation of protein, if your biomass, for example, duckweed is having large amount of rubisco protein which is water soluble, in that case you may need not to go for precipitation of protein. You solubilize it, use a membrane to remove the sugar fractions, and the left of the biomass goes straight away for spray drying and you get your protein, yeah. Or else use an alternative technology to extract. That means, you use ultrasonic to reduce this time to couple of minutes, or microwave to reduce it to couple of minutes, and then reduce the usage of solvent and then carry out with the conventional method, yeah. This will be quite clear when we see this particular system. This is hydrodynamic cavitation, is another form of ultrasonic system where we use the dynamics of water to create cavitating bubbles. Cavitating bubble, that means cavitation is formed because of dynamics of water. This was the system designed with the patent of this particular cavitator with the University Turin in Italy and with our industry manufacturer Cavimax. So, they designed it specifically for our purpose. If you will see, these are A tank and B tank, there are two tanks having a stirrer in between where you put your biomass and a water or your solvent, mainly we use water. This is just a normal pump which is pumping it through a cavitator here. This is only the pressure meter and all those things, and inside the cavitator there is an inlet and there is an outlet, and there is a rotor and stator arrangement, as you can see here, rotor and stator arrangement. Because of this, it creates lot of cavitating bubbles which either implode or explode. Explode, that means blast out because of internal pressure, or collapses because of the gradient between external and internal pressure, and during that process it produces lot of cavities. And the way it works is either it is a rotor and stator, this is static, this is moving, or this is moving, this is static, or both are moving in different directions. The number of different configurations are there. Other type of cavitator is Venturi type, that means liquid is flowing through and you have tiny constriction over here. Because of that, it produces the cavities. Take it in a way, if you turn on a tap, water flows in a laminar flow. If you increase the intensity, the diameter remains the same, what will happen? A lot of bubbles are formed, yeah. And if that is happening at very large amount of pressure, huge amount of cavities are formed, yeah. So, that can also cause a damage to the product, yeah. So, the similar principle comes with hydrodynamic cavitator. So, if you will see over here, any of the given biomass which goes into this, it creates into a slurry, yeah. That means, it disintegrates the biomass into finer particle, yeah. A similar type of stuff can also be done with a colloidal mill. If you have wheat grain, you soak it in water, or you would have seen idli or dosa batter, yeah. It is a grain, a stone grinder, it makes into the paste. Then you want to extract something, it becomes easier. Similar thing can be done with using hydrodynamic cavitator, yeah. Now, if you will see this one, HDC plus isoelectric separation or precipitation, whatever you want to call it. Technically, it should be precipitation. Sometime we put isoelectric separation. Protein content and recovery. 1 pass, 2 pass means nothing. There is no unit called 1 pass, 2 pass, yeah. That depends upon the flow rate and other condition. Just due to the commercial sensitivity of the information, it is just written as 1 pass or 2 pass, yeah. And then with this itself we can get that much amount of recovery and the protein content coming out of the biomass. Yeah. So, here we just use this one as pre-treatment for separation, and if you want to use alkali or any other acid to it, in this machine it can be used because all those seals and gaskets are made up of Teflon. So, they are resistant to any of those corrosive chemicals. Yeah. And during the cavitation process, since the water is having huge amount of dynamics, it produces heat as what happens in most of the ultrasonic cavitation. Yeah. So, this is a cavitation based on dynamics of water. Yeah. So, and then this is what different types of rotor and stator it works, and all these things causes bubble formation, and it will be much more clearer when we go into the mechanism of ultrasonic cavitation. So, now coming back to your sort of biorefinery stuff, whether it is microalgae, Cholera vulgaris, nanoscleropsis, you dry it, you get dried powder. Either you use a fresh paste of microalgae when you remove the water through centrifugation or through membrane concentration, or dry powder, you treat it with high pressure to break the structure, to dislodge the structure, and followed by ultrasonic system or with a microwave, or after that this can be considered as a pre-treatment and extraction to get your lipids. Once you get your lipid, you can go for further enzymatic extraction or ultrasonics to separate protein, or high pressure followed by this. Yeah. So, all those processes can be established, and when you are trying to do that valorization part, whatever biomass is, even if you are just going with high pressure treatment and then to see their digestibility, because these technologies not only improve the extractability, but also can improve the digestibility and functionality of those biomasses, because microalgae on its own itself is protein. Yeah. If you take for example, spirulina, which can contain up to 60 to 70% protein, and protein concentrates are already 60 to 70%. Cholera vulgaris, depending upon again the strain, it can have between 25 to 45% protein. Yeah. So, if you just have a simple stuff of using viscozyme, have you heard of viscozyme? Viscozyme is a sort of is a commercial name for from Novozyme, that is carbohydrases, which is a mixture of cellulose and all other carbohydrates, which can break that carbohydrate and then leave the protein, and carbohydrates are broken down into sugar. So, simple membrane system can remove the protein from sugar suspension to concentrate the chemicals. Yeah. Or else you give just ultrasonic treatment or microwave treatment to dislodge the cell, that is to disrupt the cell, and then to use enzyme and then to separate the fractions. Yeah. So, there are number of different combinations. So, each one itself, microalgae fresh or dried, subjected to treatment, and how much is your recovery yield, is a study on its own. Fresh or dried with ultrasonics and extractability is study on its own. Yeah. So, all those combinations how it can be used, and lot has been published out of this, and all these ultrasonic, and this should be kilohertz, sorry, it should not be hertz. So, ultrasonic bath, probe, microwave, and combination of both you will see in coming slides. Yeah. So, now this will give you an example how pre-treatment, this very simple experiment is which you saw the previous slide was all different combination. This was carried out on Cholera vulgaris, normal system, 20 or 100% power for 10 minutes. Now, again percent means nothing unless and until you know what 100% means. Yeah. Intentionally we do not write all those values, because just for what are exact conditions. So, that means if you have 100% power is related to 130 watt per centimeter square. I will cover all these units when we go through in detail with ultrasonics. After doing these two pre-treatment, enzyme, proteases, within proteases there are multiple type of enzymes are there, that is alkalase, which operates at alkaline pH. You have papain, pH neutral, yeah, or you have other protease from bacterial source, bromelain, some of those enzymes they operate at acidic pH, yeah. So, depending upon the pH, you can select an enzyme, operate to see how much of protein hydrosolate or concentrates are required, and then you recover protein. If you see, this is simple figure, control which was almost an 18 hours, follow compared to these two, what is the protein recovery, whereas 10 minutes of this treatment compared to 18 hours of this treatment is having significantly higher recovery yield. Then further characterization into amino acid digestibility and all is not presenting it here, is not showing, just conscious of the time as well, and that is where single pretreatment can improve extractability of it. Yeah. Another one is to do with how it looks like, the same figure. When water was used, hydrochloric acid was used, or alkali was used. Yeah. Different solvent, 2 hours, 18 hours, 10 minutes, that is ultrasonics, 2 hours, 18 hours, 10 minutes, 2, 10, 10, sorry 2, 18, 10, control and ultrasonic, and you can see the differences. So, here 18 hours and 10 minutes was the same. So, that means you are reducing significant amount of time, and in order to see how it changes the structure, these were the images taken using scanning electron microscopy, which cannot be seen very clearly on this particular screen, but you can see how ultrasonics can damage the surface to improve the extractability of the biomass. Yeah. Just take the message, pretreatment followed by this. These values will differ depending upon your biomass and intensity of treatment, and when we talk about ultrasonics, we need to be seeing what is the frequency and what is ultrasonic intensity and the power. Often power is reported in publication based on the equipment power. That is completely wrong. If equipment is 1000 watt, you do not use 1000 watt. That is a power rating, that is the maximum power it will draw out. Yeah. If you use it at a lower intensity, it will be half of that. Something you have heating radiator which says 3000 watt. That means in 1 hour it will use 3000 watt per hour. That means huge amount of electricity. But if you are putting it in second regulator setting or third regulator setting, you may be using only 10% of that power. So, that power used by the equipment can be easily measured by buying a simple power meter which is plugged when you are drawing the current out of it. Yeah. So, those are the way to measure a power, and how much is delivered to the product, that depends again measurement by calorimetric method. I will cover through when we go through the cavitation part. Yeah. I hope everybody has seen ultrasonic system, whether a bath or a probe system. Yeah. So, that is one. Now, this is again to do phycobilin protein from microalgae, that is Porphyridium purpureum. This is pink color microalgae, and here this is normal shaking, and this is to do with plasma. Yeah. A specific example I loaded here only with the plasma, because you did see the plasma system, and subsequently I will be covering some of the plasma technical system here. All this UV LED light, high voltage electric discharge, atmospheric pressure plasma jet system. Yeah. There are number of different ways the plasma can be imparted. You have seen 1 or 2 systems here, and wherever you go, there is everybody makes their own plasma system. It is not that complicated to make it. And the plasma can disrupt the cellular cells, like what plasma can break microalgal cells, same way plasma can also break yeast cell or bacterial cell. Yeah. So, when it breaks the cell, it releases the compound, and compounds are present within the microalgal cell. As you can see, different powers, different gas configurations, they have different extractability of microalgal cells. Yeah. So, this is and if you have any specific interest, I can show it to you all. I can give you even electronic copies of some of those publications which you can see, and if you have any specific question, you feel free to ask. Yeah. Now again, high voltage electric discharge either by shaking or different time points, different plasma set, that is phycobilin protein, and these phycobilin protein are pink color protein. That means PE, PC or APC, that is all phycocyananes, that is color bearing protein compounds. Yeah. So, these are all different extractability yield in aqueous extract, and this was only done at the research stage to see whether it can be used or not, but obviously for commercial scale usage of plasma and all are still subject to number of different regulations, that is through novel food regulation. So, you can see on how the air or nitrogen. So, when you saw the plasma system, you can generate a plasma species by using air, nitrogen, oxygen or combination of different things. Yeah. What difference it will make? Any idea? It will differ in the reactive species. Yeah. You have seen the plasma system, what type of gas used, that will depend upon what reactive species you are making. Think if you are using only nitrogen, what reactive species it will form. When you are using CO2, what reactive species it will form. When you use oxygen, what reactive species it will form. Or if you are using air, which is combination of all these three gases, what reactive species it will form. Yeah, which is responsible for breaking of those cells. So, now once we extract those ingredients, 2 or 3 days ago one of your colleague was asking about the cytotoxicity. So, that is why whenever we extract ingredient, it is always done on cytotoxicity on cell line cultures, and to see whether those concentrations whatever is being extracted, do they have any impact on cytotoxicity, not because of ingredient, but because of the process technology which has been used for that purpose. Yeah. Does this answer the question of biological activity? That was you, right? Yeah. So, the extracted ingredient, what is their property, and if we are using any new technology, does that technology along with the ingredient causes an issue on cytotoxicity? Yeah. Okay. So, that is one which shows how we can use either jet system or gases or nitrogen. Do they have a specific cytotoxicity? If they do have cytotoxicity, what is causing cytotoxicity is A, and B, what is the concentration which will cause cytotoxicity. Yeah. So, that is all to do with cell line culture. So, this is what shows what is the cell viability and against different cancer cell lines. So, any questions so far? I just wanted to give you only 2 short examples, and then when it comes to scanning electron microscopy, again as you can see how the control looks like, and when we give a plasma treatment how cell gets damaged. Now, these SEM images are not very clear, because when the extracts are obtained or when residues are obtained, you have to dry it. When you dry it, the scanning electron microscope will not be able to pick the refined exact impact on the biomasses. For that, you have to use scanning electron microscopy with clear intention or sample preparation, or what way samples are dried, because wet samples you cannot put it under scanning electron microscopy, because of the moisture present, it will have different diffraction and the print will come out completely different. So, you will see much more clear pictures in next couple of slides. Yeah. Now, that was microalgae. Now, if you look at the macroalgae, whatever biorefineries were carried out, and this shows the application of different technologies, different stages of macroalgae. Seaweed remains the same, that is Alaria esculenta. Post harvest operations, what we discussed other day, washing, hot air drying or milling, soaking into 0.1 molar hydrochloric acid. Ratio here was 1:14. That answers your question, because that was the minimum what we can use to compromise between the yield and requirement. If you go 1:20, we will have a better, but we have to remove solution again. Process over here, thermal processes, that is 70 degree for 2.5 hours, hydrodynamic cavitation for 50 passes, which takes nearly about 30 to 45 minutes. First stage processing, we get a pellet and we get a supernatant. If you see in the supernatant, this supernatant was either directly freeze dried to calculate the extract yield after the treatment, ethanol precipitation to precipitate your laminarin, and the third one, membrane ultrafiltration by using 10 kilodalton membrane, because we know that more than 10 kilodalton is the molecular weight of laminarin, and after that whatever is left over less than 10 kilodalton was your mannitol and retentate was laminarin. Yeah. So, this is what was for stage 1 process. Leftward to extract alginate, 2% of sodium carbonate. Again I repeat, you can also use sodium bicarbonate. There is no standard ruling what method to be used, because that is again been optimized for that particular seaweed. Again 60 degree for 3 hours or hydrodynamic cavitation for 50 passes. Residue was protein and fiber, we left it at that. Supernatant, direct spray drying, crude alginate, ethanol precipitation, pure one, pure alginate, and then to measure the properties of alginate by using your FTIR or TGA and all those analysis to compare with commercial alginate to prove the point how is your process. Now, if you look at all these key points, that was done again with same hydrodynamic cavitator. Yeah. So, this is again tank which I already explained you. Yeah. Now, these are the extracts which are obtained directly conventional, ultrasonic bath and hydrochloric acid with alternative acid, that is citric acid, and this was a compound which was purchased from Sigma Aldrich, hydrodynamic cavitation HC and with the probe and hydrochloric acid. Diagram you saw was all related to hydrodynamic cavitation. When you go in here, laminarin, number of different treatment. When we use hydrodynamic cavitation, we had much better purity compared to direct freeze drying or ethanol precipitation. Energy consumption was very low, because when we used hydrodynamic cavitation, we were using for much lower time. When we use the heat plus 2.5 hours was having higher amount of energy, and this energy consumption is calculated based on the power drawn from the power socket. That means, the specific type of power socket comes in the market, you plug it onto the power phase and then plug in your equipment. That becomes slightly complicated when you are using 3-phase current or 5-phase connection or higher amps configuration. So, that is the way you can calculate power required. Mannitol, that is sugar alcohol, membrane 40% purity, recovery rate 75%, sodium alginate 88%, recovery rate, energy consumption and its molecular weight. Protein, how much we recovered, because normal alaria was having only 5% protein, 5 is concentrated to 17 and rest was fiber in it. Yeah. So, either we want to make a fiber rich powder, we eliminate the protein by using enzymatic processes, or use your enzymatic process to break the fibers into sugars and retain the protein, and the sugars can go for your bioenergy or ethanol production. So, this is the way how the technology can be used for making different biorefinery approaches. Yeah. And where are always the benchmark was to see what is the commercially available product. So, here it is 190 molecular weight, and there is no product sold in the market with mannitol or laminarin is available. So, here sigma, this was a molecular weight, and molecular weight what we obtained was quite similar. Yeah. Any questions so far? So, how the technology can be used? Again, if your target is only on laminarin, that is beta glucan, and how do you estimate laminarin? Either by using HPLC or megazyme kit. You might have heard about megazyme kit. Yeah. Megazyme is a kit which can help you to measure total carbohydrate, soluble fiber or beta glucan or insoluble fiber, because in our labs we have eliminated all those analytical method which involves sulfuric acid or corrosive acid, because when we talk about sustainability and cleaner extraction, that also to modify the analytical techniques which does not include such harmful acids or chemicals. Yeah. So, that is laminarin, that is mannitol, and further usage of mannitol is to crystallize it to get your mannitol crystals, or to convert this one into maltitol, which could be a replacement of xylitol which is used in chewing gum or any of those sugar alcohols. Yeah. So, these are all different ingredients and processes used using technology. Now, this you give you another example where the wild harvest seaweed, that is Fucus vesiculosus, was used to extract fucoidin, that is fucose containing sugar or sulfated polysaccharide. Yeah. This is very simple one where you have different power levels for ultrasonic, that is 100% amplitude corresponds to 38 watt per centimeter square, that is ultrasonic intensity. How this is calculated, I will go through that process. So, here when only ultrasonic was used, these were the recovery yield. The moment we use microwave alone, recovery yield was almost 9 times, yeah, and this is only 2 and 5 minutes, not a huge amount time. But when we combine ultrasonic with microwave, recovery yield is significantly increased. Yeah. Now, this is possible for fucoidin, but may not be possible for phenolics from microalgae or phenolics from tea, because this particular ingredient, conventional extraction process for fucoidin is boiling your seaweed extract at 80 degrees Celsius in 0.1 molar SCl for 6 hours. Yeah. Because this is not temperature sensitive compound. Yeah. That is the reason microwave, which introduces huge amount of energy and a temperature, still you are able to achieve that particular compound. And this is one of the most expensive ingredient in terms of having biological activities as well as again antiviral activities and lot of antimicrobial properties and plus range of different biological functions. Yeah. So, the selection of the technology here, no enzyme is used, only ultrasonic for disrupting the biomass or combination of different techniques. Now, if you look at what happens, this is not from the seaweed, this is another structural change which work was carried out on coffee silver skin, that is outer cover of coffee. Normal biomass looks something like this, flat. So, the solvent has to go in. When you use microwave, the structure is bit damaged, ultrasound damaged, ultrasound followed by microwave, yeah, subsequent, see the structure, microwave followed by ultrasound or simultaneous ultrasound and microwave. Yeah. The whole purpose here was how you disrupt the matrix so nicely, so that it absorbs the solvent at much faster rate, solubilizes the solute and you remove the residue. That is the whole purpose of disrupting the cellular matrix. So, I think this is pretty clear here, and how much biomass can be disrupted. Whereas, if you have raw biomass, it takes longer to dissolve it, to expand the network, then solvent starts going in. That is why it takes normally 16 to 18 hours to achieve the same extraction, which microwave can do it in much shorter time. Yeah. Again, the selection of technology will depend upon your choice of solvent. When you use ethanol, 100% you cannot use microwave, it will catch a fire. Yeah. When you use hexane, you cannot use microwave straight away. Polarity of the solvent, dielectric property of the solvent, all those are important features before you use any technology. Yeah. Biomass, target compound, selection of solvent, These three becomes important parameters in order to use different technologies. Yeah. So far what we talked all about was the wet chemistry and wet fractionation, which is quite commonly used for almost every processing. There is another way of using or separating proteins and different ingredients, that is your dry extraction technique. Dry, one, you have a biomass, you do a pre-treatment, grinding, milling, microwave, ultrasound, any of those treatment, and then you do the separation process. This technique is known as air classification. Yeah. At simple experiment is you take any flour or any grain, for example, grind it. Yeah. When you grind it, what will be the particle size of it? You will never measure the particle size. But if you take different staked sieves, yeah, and you know BSS sieves are there for using for filtration. So, if you take a sieve of 300 micron, 200 micron, 50 micron, 10 micron. Simple experiment what you can do, you do not need to buy a expensive air classification system. You have multiple sieves arranged on top of each other. If you put your 100 grams of either a seaweed flour, pea flour, lentil, chickpea, whatever you want to add in, if you add in here, yeah. If you shake it, what will happen? Out of 100 grams, 30 grams may be here, yeah, 20 grams here, 10 grams here, 5 grams here, yeah. The rest you can balance it out, right. So, each of the fraction, this is the particle size distribution of your flour, that is a function of your milling machine, yeah. Now, if you do the composition analysis of this, an original flour contains suppose 30% protein, 60% carbohydrate and your 10% your ash, just take rough estimation. So, which fraction or will each of the fraction will have the similar composition profile? Yes or no? No. The reason is when you grind anything, the fiber fractions are difficult to mill it to fine powder. Yeah. So, this fraction will have larger amount of carbohydrate. Yeah. And then over here you may have more of the starch and a protein. Yeah. So, that way you can concentrate the protein, and since it will contain only fiber and a bound protein with those fibers, and if you use enzyme over here, you can recover the protein. Yeah. That could be your cocktail way of doing cocktail between dry and wet processes. What air classification does, it makes very, very fine flour, and there are different air cutters are there. So, that means starch and a protein is separated based on the density. Starch is having different density, protein is having different density. So, by that, if you will see here, this is from this particular research paper, you have protein, starch and other biomass. When you pass it through, and you can see how you can separate different fraction, and then again if you have to do charge particle separation from starch, you have electrostatic separation or different biomasses. Yeah. And here you can see coarse fraction, flour and fine fraction. So, all these fine fraction, they contain large amount of protein, yeah, because they have lower molecular weight and you can grind it properly. Similar one, if you dry a fish and grind it and put through the particle size, you can see all the collagen scales and bones will be left on the top, and subsequently you will get only the protein fractions. Yeah. And then when you get a protein fraction, if you want to further purify it, then you may not need that long extraction technique or long solvent to separate the proteins. Yeah. So, the best way will be to use both dry and a wet fractionation. Yeah. Do you all agree? So, that all depends upon how you want to use different available techniques. Yeah. So, air classification separates the stuff based on density, and purification up to 50 to 60% can be achieved by only by grinding. So, you can make a protein concentrate by using dry classification. It will not be possible to make 90%, 95%, but rest of the biomass is rich in fiber. So, accordingly you can develop your biorefinery processes. That was the purpose of showing you this particular slides. Even if you are taking the P here, this over here, the coarse fraction, large amount of fiber, small amount of protein. Very, very fine fraction, you have large amount of protein and bit of fiber here, but this fiber is mainly a soluble fiber which can be grounded easily. Yeah? And if you take this particular fraction, and then here if you are using your viscozyme or carbohydrases, you can break this carbohydrate to release more of the proteins. Yeah? Or you can concentrate whatever you want. But if your purpose is to use that particular protein for making your meat analog or alternative product, it is recommended not to go for 90% protein, because you need to have water holding capacity, oil holding capacity and textural properties, and all those biomasses will provide you that type of properties. Otherwise, you get a 90% protein, then you buy a starch and to add it to make a alternative protein, right. So, protein purity should be only based on end product application. If you are looking for protein beverages for health drink, then you can be 90-95% protein, or then use a completely hydrolyzed protein which can make into the solution and you drink it as a protein rich beverage. Yeah? Purity should not be based on how pure you want to. Yeah? Like you go and buy jewelry, most of the gold jewelry is 22 carat or 24 carat. It is not ultra pure gold. If it is ultra pure gold, you can't make any of those jewelry. I was about to say abhushan. Yeah? So, based on that, level of purity depends upon what is your end product application. Any questions so far? I know I went a bit fast, so that's why I wanted to ask you a question before I move, before I continue with this. So, you have pre-treatment technologies, wet stroke dry, yeah, and previous time we studied biorefinery. Now, we are just adding technology and processes at different point to continue using the technology to improve process efficiency or to extract ingredient. So, you have seen example from microalgae, macroalgae, and some examples from other grain crops. Yeah? So, principles remains the same, technology remains the same, changes in biomass will lead you or which will compel you to change your extrinsic factors like solvent, type of solvent and conditions to be used. Yeah? So, if there is no question, now I have a question, why do we need new technologies? And how we classify technologies. First and foremost condition is regulation. Yeah? It is not point number one, is one of the point. Regulation, that means if there is a regulation that you should not use a chlorine or you should not use A, B or C chemicals, so you need an alternative. Yeah? Because of regulatory aspect, we need to go for alternative approaches, then you have to rely on new technologies. Second, cleaner and greener approach. In order to improve the process efficiency, to make process more greener and cleaner, technologies plays an important role. Third element is food safety and shelf life extension. Yeah? Fourth one, when we use the technology, it retains the nutrient or maintain fresh like taste. You would have seen in number of different studies, high pressure processing retains fresh like taste or maintain the sensorial properties. Other element is consumer concern. Consumers are concerned with the usage of lot of chemicals in their ingredient. So, you have to use some of the technology where you can eliminate the usage of chemical and improve consumer confidence in your product and processes. It is not important what is the product, it is also important from where it has been obtained, its geographical origin A, B, how it is being processed. Yeah? These things are also becoming critical. Yeah? Another one is there are a lot of technological advances are happening to improve the energy efficiency or process efficiency, and processors want to employ new technology to their processes again to make more profit and to be more economical and environment friendly. It is something like when a new phone system comes in a market, you want to go for that technology. Why the previous was not working? It was working. So, new technology is coming in from 3G you go to 4G, now you go to 5G. Yeah? So, that is the one of the drivers for new technology, and one of them is environmental impact. So, environmental impact of current processes are having huge impact on environment, and you try to adopt new technologies so that your environmental impact of processes is reduced. Now, when it comes to novel food technologies can be again classified based on the energy, that is thermal, electromagnetic. Any idea on electromagnetic? Electromagnetic spectrum is used in light based technologies, and you have your microwave or pulse electric field. Biotechnological, enzymes and microorganisms, or mechanical. Technology on its own or combination of these technologies to derive smart solutions to achieve any of those stuff. And when we use new food processing technologies, indirectly they impact all 17 sustainability developmental goals, but directly on responsible consumption and production and good health and well-being. Yeah? That means all these points, 7 points listed here, the core drivers of new technologies, how it is related to your sustainability developmental goal, and how we classify these technologies. Yeah? So, this is again the recap. So, what is the main purpose of using new technology? Reducing the waste or transforming the byproduct. This using better what we use already. Yeah? And this was mainly to unlocking the potential of seas and ocean. Yeah? Or new biomasses. Yeah? So, at least after this 10 days module, at least you will learn this reduce and transform. Yeah? Okay. So, that is one. And then first one to do for reduction. When it comes to reduction in that term, one is improving the safety profile and process efficiency. When I say reduction, reduction in usage of energy and water in the food processing, reducing the waste, or developing the new applications or new food product. Yeah? This is what meant by reduction. Now, this is a mouthful of different technologies. It's good that some of the technologies are already mentioned by you guys, what are the technologies used. I am covering some of those core which were said in a first go and are well known and have lot of different applications. One is high pressure processing. What is the mechanism of high pressure processing? Very good. Pulse electric field, what is the main mechanism and what does it mean?
We can apply electric voltage in the membrane, and in the membrane there will be a small pore be generated. It's called the electroporation.
simple word, if you read the word itself, yeah, pore because of electric current. When given electric current, everything contains positive negative charge. Because of that, it forms pores. Ultrasonics, sonoporation, pore formation because of cavitation. Yeah. Cold plasma, UV or ozone, they have a single mechanism that is related to oxidation. Oxidation of compound which are present in bacterial membranes. Yeah. Very similar membrane principle will also be applied when it comes to extraction usage of these techniques. Yeah. And we are comparing all these technologies against heating, that is thermal processes. Yeah. That is why it is known as non-thermal processes, that is alternative to conventional thermal processing. Can you name 3 thermal processing techniques? Who will name 3 thermal processing techniques?
So pasteurization.
I told you the other day it's a process. Yeah. All these techniques will do pasteurization, sterilization.
This one is microwave.
Question is, name 3 thermal processing techniques. You said microwave. Microwave is novel thermal.
So autoclaving.
Correct. Okay. You can call it. I can call it as a canning as well. Yeah. Canning is a process to achieve sterilization or pasteurization. Yeah. Canning will be a technique. I know often most of the literature and everywhere will read pasteurization and sterilization as thermal processing. No, we are achieving then what we are doing with high pressure. Yeah. We are either achieving sterilization or we are achieving pasteurization. Yeah. So 3 thermal processes. We keep giving out to thermal processing, but we have to know what are the thermal processes. Yeah. One is canning. Any other? We can, yeah. Blanching is one, correct? Yeah. Guess.
Home heating.
Huh?
Home heating.
Novel thermal. Yeah. That's good. Just guess it. At least will might something new might come up. Yeah. And technically, canning is the one which is canning, retorting, and blanching, or impact heating. All these will be classified as thermal, because there is thermal, that means only you apply direct heat. Yeah. Way you apply a heat becomes a technique. Yeah. Within retorting, that is a static retort, rotational retort. Yeah. Agitating retort, steam infusion into the product, that all, or what you call steam infusion into the product, that all comes into thermal processing. Yeah. Whereas pasteurization and sterilization is the process which has to be achieved either by thermal techniques or by non-thermal techniques. Ohmic heating, induction heating, what else was there? IR heating, dielectric heating, microwave, all this will be considered as novel thermal techniques. Yeah. Achieving the same heat effect, but by using efficient methods. Now, there are 2 types of cell. One is vegetative cells and spores. Spores are seed of vegetative cells. When they germinate, they create vegetative cells. Now, majority of these techniques, they all inactivate cell by damaging their cell membranes. Yeah. Same thing if you consider a microalgal cell or any biological cell, non-bacteria or non-bacteria or non-yeast, you damage the membrane, that is, you disrupt it to do the extraction. Yeah. Same thing applies for bacteria. Yeah. Inactivation of key enzymes modulating the growth of cells. Oxidative damage to cell membranes. Plus, these are just arbitrary values, what all is being reported in a literature. And I am not obviously a biggest microbiologist. Well, I know a bit of microbiology, but I am not an expert microbiologist. Vanempe from Belgium, Greiner, and yeah, these two are very well known microbiologists, establishing different mechanism, working on single bacteria, avoiding bacteria to bacteria combination. We came up with that one to see what are exact mechanisms for each and every technology for adoption. When we suggest any technology, we need to know what is our target. We have high amount of microbial load, we can use high pressure. That is just shooting without thinking. Yeah. If you are using a milk and high pressure is still not approved, because high pressure cannot inactivate spores. Yeah. And botulinum is caused because of spores. If you are able to inactivate spore formers, that technology can be used at commercial scale and can be approved by FSSAI, European Commission, or any of those agencies. Yeah. So, thermal processing is still in use. Your normal pasteurization by using your HTST, low temperature low temperature LTLT, HTST and all those ones, yeah, or ultra high temperature. Yeah. These all techniques are still in use because some of the technology cannot achieve spore inactivation, whereas heat can kill everything. Yeah. Now, so what will be the solution? How we can use high pressure or pulse electric field or ultrasonics for liquid processing? One of your colleague is working on thermosonication. Yeah. That means combination of heat plus ultrasound. So, that means to reduce the thermal impact and taking a part of heat, and rest all is carried out by ultrasonics. Yeah. This is very similar. If I need to unscrew something on this wall, either I need such a long screwdriver made up of metal, or half I can use a wood and attach a screwdriver to it and then open it. Yeah. Can take that one as a good example or a bad example. So, you just make a use of it, or else you make a big stool and then you can use it for different purposes. Yeah. So, that is why I wrote it there, smart combinations, so that you need to know at what cost it inactivates. So, this we have already seen last time. Yeah, I am just repeating it again. Now, microbial inactivation, once you know what is inactivated, then you have to use how it is impacting your minor compounds or major compounds. Yeah. Again, similar mechanism. In most of the cases, these technologies, they have minimal impact on bioactives and nutrient. One of the reason is, even if they are degrading those compound, but these technologies are also allowing to open up the structure to release those bioactives. If suppose 10% is degradation, and we use these technologies also for extraction purposes. Yeah. That is another reason why bioactive compounds are not impacted by this. And the study, in order to see whether it causes protein oxidation, proteolysis, denaturation, or oxidation or lipolysis, are achieved using these techniques, but at a condition which is not required for microbial safety. For example, for high pressure at for 10 minutes will cause lipid oxidation and protein depending upon type of the product, whereas when we use for 2 to 3 minutes, it will not cause inactivation, or it will not cause the degradation. A. B. Treatment on whole product versus ingredient. If you treat juice with cold plasma, you will see degradation of vitamin C and bioactive by 30 to 40% to 50%. But if you use whole orange, you won't see that degradation. Yeah, it just depends how you are treating it. Using a hot water to wash hand is okay, but you remove your skin and then wash it, then you know what will happen. Yeah, or the ingredients versus whole food. So that's the way this, the processes are designed. Now, I will quickly go through one or two processing application, and then we will continue it in next lecture. So, one is decontamination. You know what is the biggest disadvantage of new technologies is majority of these technologies are useful for liquid food product. Yeah. But what is alternative to chlorine? Because chlorine is a low cost and how you can use it. So, either you have a non-thermal or thermal. Thermal, water. One of them is blanching, dipping into the hot water. Non-thermal, biological, that is your natural extract, bacteriocin or so. Physical, that is ultrasonics for washing or removing the bacteria from the surface. That is why we call it also sometimes ultrasonic bath, giving the bath to the product in ultrasonic field, it removes washing. Other one is chemicals, either ozone, plasma activated water or organic acids dipping into it. Yeah. That is contact type. Yeah. That means product comes in contact with those chemicals. Other one is non-contact. Preferred will be non-contact. That means the product is not coming in contact with the chemicals or with the agent. Here is a steam. Yeah. Steam bath or steaming the product. That means to inactivate microorganisms. That is non-contact. Physical, ultrasonic and cold plasma. That means same plasma in a water becomes contacted, that is plasma activated water. That means plasma, water is charged with the plasma and then to use that water for washing purposes or putting the product directly into plasma rich environment. Yeah. Same thing applies for ozone. Yeah. So, when it comes to seafood, if you all think about the fish or the shellfish, comes out highly perishable commodity, you wash it in the ozone water, then freeze it, wash it in a chlorine water which is not allowed because chlorine will leave lot of residues into the product, and then to freeze it to stabilize the biomass. Yeah. So, this is what to do with decontamination technologies. This is one of the example of high pressure processing. In order to prove that particular high pressure can be used for pasteurization or sterilization. Other day I mentioned about 5 log for pasteurization. Yeah. For sterilization it was 12 log, but that is only true for liquid food when it comes to non-thermal techniques, or canning or retorting is for 12 log which contains lot of brine solution. But when it comes to solid food, how we can achieve sterilization to achieve 12 log? There is no limit for that. Even chlorine washing gives you half log, that is 50%, or 1 log, that is 90%, or 95%, that is 1.1 or 1.2 log. So, in order to prove that high pressure, this was again a system was designed using a high pressure and a temperature together. How many of you know about Bacillus amyloliqueficans or Clostridium sporogenesis? These are the bacteria whose spores, even if you heat it at 110 degrees Celsius for half an hour, it will not cause inactivation. And these are the index microorganisms used to check the efficacy of your autoclave. How many of you have validated your autoclave? Autoclaves are validated. You would have known that when you turn on autoclave to maintain a pressure, you remove all the gases. Yeah. So that only steam is left, just to maintain the condition, and you check the validity or autoclave, that means calibration of autoclave by using these type of microbial film and to see how much inactivation happens. If you look at this short video, yeah, I'll remove all this, yeah.
HPT, hydrostatic pressure combined with temperature, will enhance the quality, shelf life and safety of food products, whilst reducing their global footprint. We are currently designing new equipment to introduce HPT to the global market. And this is how it will work. The food product, sealed in flexible and water-resistant packaging, is first inserted in a container and then preheated. In the next step, the preheated food is subjected to an enormously high pressure of up to 6,000 bar. This pressurization lasts just a few minutes and results in an instantaneous increase of the temperature up to 120 degrees, enough to destroy the most resistant microorganisms and enzymes. The short pressure and temperature treatment ensures that the quality of the product is hardly affected.
Now, whatever you see in this
Through
video,
extensive
on
research,
these
we will
two
be able to
bacteria,
determine the ideal pressure, preheating temperature and time span for each individual product,
if you'll
avoiding
see
pathogens
over
and
here,
obtaining the best possible food quality and safety.
time 80 to 100 minutes.
Combining our
achieve
new technology with these best practice methods,
even 2 or
both the
3
food
logs,
industry
yeah?
and the consumers will benefit from HPT
Whereas,
processing.
When
Hipster,
you use the high
making our
pressure
food safer
along with
and
such a
tastier.
temperature, we can achieve much longer log reduction at much shorter duration. Yeah. What does it mean? That means heat plus high pressure. If you go back to the literature, you will say TAPS, temperature assisted pressure sterilization, or PATS, pressure assisted temperature sterilization. That means combination of temperature and pressure. Why the limit was set as 600 megapascals? Because if we go for 700 or 800, even further we can reduce the time, but strength of the material becomes challenging. The design aspect here was whatever vessel is to be used, that is preheated to a temperature, then it goes for high pressure. Otherwise, you have to heat up the whole vessel where we are generating a pressure. By doing so, amount of energy required to heat up the whole vessel and the strength of that material, number of cycles are reduced. So, what you see here, temperature alone takes longer time. That is why you use autoclave to put some pressure and to get 15 to 20 minutes, but that time product is completely spoiled. Yeah? And this was tested on different type of soups. Yeah? That means using Bacillus amyloliqueficans. Then only we can use high pressure for industrial application. Yeah? So, this was mainly a validated study with known DSM strains which are used for testing the efficacy of sterilization, and to see the shelf life of these products. Ready to eat soups, they are only few months or 6 months when it comes to canned product, whereas when you use high pressure they have much better quality and amount of heat required is less. Yeah? So, this shows the combination of HPP with temperature. So, this had different 11 partners. One was equipment manufacturer who designed that particular system based on the conditions which were provided for soup mixes. Yeah? So, the whole crux of the story here is when we use temperature and high pressure together. The same thing on other type of spores. So, instead of having 50 to 60 minutes, we can get everything done within few minutes. What it does, high pressure will germinate the spores and heat will kill it. Yeah? When you use heat alone, then heat has to break the spore coats at very high temperature and then to kill the vegetative cell. That is why the combination of high pressure and temperature is done. If you only give high pressure to spores, their germination increases. Some of the study, if you will see, when you use ultrasonic washing of fruits, microbial growth increases, because if suppose microorganism is at one point, put in ultrasonic bath, that microorganism will detach from there and spread all over the surface. Yeah? So, that is the way what it can be used. Okay, I will quickly go through the fish example here. Very similar process applies for fish to extend shelf life. You have already seen a video. What high pressure is? You have fish, you vac pack it, give a high pressure treatment, improves the shelf life. You can get up to 2 to 5 log reduction, but not long term shelf life, but short term shelf life is good. Or even if the fish is to be used for subsequent extraction, it improves the extraction efficiency, at the same time it also improves the shelf life. Another advantage is it also changes the properties of the ingredient. So, with this high pressure we will stop and will continue with the application of new technologies using cold plasma in next lecture. Yeah. And remember, tomorrow morning when we start, we will start each one of you as a question and answer session. Each one have to have a question. Yeah. If you don't have a question, I will ask that person a question. Yeah. Each one will have a microphone for few seconds to a minute. Yeah. So now you can strategically you think who should be the first one, who should be in the middle. Yeah. Okay. So any question for today? No. Yes.
Sir, we use plasma technology for inhibit the microorganism and reactive oxygen species. But in previous slide, you saw that it also lead the DNA damage. Okay.
Yeah.
So DNA damage will lead the mutation in algae. So if mutation will be occur in algae, it will decreases the efficiency of the algae. So why we use oxidation rays and plasma technology
For microalgae.
uh-huh.
Yeah, the reason is because microalgae, when you are saying about it, now here the two things are there. When you use a plasma, suppose you have a bioreactor, you grew one species, you took the biomass away, yeah, then you have to use another species, so you have to kill those algal cells. Yeah. Here plasma, when it is used for extraction, is to damage the cells, to break the cells, to release the stuff out of it. Yeah. When it comes to the damage of DNA, that is oxidation of those DNAs are one of the possible mechanism for inactivation of bacteria. That is why there was only 2+ there. Yeah. But it could not be a core mechanism of degrading the DNA. That means if you take DNA solution and give a plasma treatment, it will show you the oxidation of DNA strands. That is the way it is known as DNA damage. Yeah. It is not exactly as a mutation, but because mutation happens not only because of oxidation and from generations to generations. Yeah. So mutation is one thing, but not the genetic mutation that when you give a treatment with the plasma, DNA will get damaged, and that means next generation is going to be a different one. Yeah. Well, it does happen when it comes to microorganisms, because in food safety we study only microbial inactivation, and up to 2 log or 1 log of listeria is allowed in a food which is allowed to be consumed. Yeah. But when you see in microbiology, most of the bacteria are inactive but culturable. Yeah. And they can mutate. So that is why most of the time when we were even in COVID virus testing, we were going for PC analysis. Yeah. Because of that, it is all keep mutating. Yeah. So that is 2 different things. Correct. DNA damage is not because of genetic trait. DNA damage is one of the way it does not allow it to grow. Cell rupture is there, or DNA can be picked by other stuff. So that is the 2 different things. We use only microalgae for extraction purposes, and in order to extract we have to break the cells. Yeah. That is what it meant there. Yeah.
Okay.
Yes.
The fish used for this high pressure processing is alive or dead?
Sorry, can you repeat it again?
The fish under high pressure processing is alive or dead?
Fish will be dead. Why you will put live fish into this? You will be in. If you put live fish, you have to go through the animal ethics. Yeah.
Yes.
because the fish here is the fish which is harvested, packed for high pressure. This is just to show the fish. If I put a fillet, it may be animal fillet, it can be fish fillet. Yeah, this is a fish high pressured in order to improve its stability for short term if you are going to use it for protein extraction. Yeah, because if you do the protein extraction without having proper stabilization and you are retaining the biomass for certain days, it will start smelling and microbial growth, that bacteria will continue into that protein as an ingredient, then you have to process it for ingredient. Yeah. Other one is using high pressure to have fish fillet, and that fish fillet goes for pressure treatment to improve its shelf life. You will see I'll put in few more examples of fish fillet, how it improves the smoked fish and other product. Yeah.
Sir, if the water bottle there is open, we
Where is
press
water bottle?
there in front there water.
This one?
Yes.
Huh.
If the water bottle open, we apply pressure, the water comes out. The same way the fish we compressing, the inside stuffs may or may not come out. What happens? We any pre-heat that or directly we apply pressure. Sir. We apply any pre-heat before applying that processing, or directly apply pressure, sir.
Okay. Now, one thing is the whole fish, A, and B is the fish product that is fillet. The process involves, you have a biomass, you vacuum pack it. Yeah. When you vacuum pack it, and then you go for high pressure. If you go for very high pressure, for example, if you go for 10 minutes in a fish, what you get out is a fish paste. Yeah. So, if you put a whole fish, you put it for 2 to 5 minutes, and that is the time to see if integrity of product is maintained. But it won't be the same fish as what it was before. It's something like you have a strawberry, if you put in a hot water, it won't remain the same strawberry. A spinach, you put in hot water, it won't be the same spinach. Yeah. So, there will be change in the product, and that's what is also known as high pressure for cooking the product. Yeah.
This fish example for this processing, sir. Common fish.
For fish, you have a fish pate, yeah, or fish fillet. You know, when you buy fish in a market, you buy either fish fillet like salmon fillet, that is vacuum packed and then pressure treated and sold in a market. Not convinced?
Convinced. Thank you, sir.
How can you be convinced? So, I know you are thinking from the product side of it. Take any product, majority the fish in India is sold as a fish and you cook it at your home. Yeah. To make fish curry or something, you make a fish curry and you want to sell it like what you get in Haldiram and different ready to eat product. In those cases, what you saw in that video, that is cooked curry put into the packet, instead of doing a canning process, you do it in high pressure. Yeah. Okay. So, that is one of the way high pressure is used for making direct product application.